47% and 46% of oil and gas plays or petroleum reserves are found on passive margins and foreland basins. Now you might not be familiar with these terms, we'll talk about them now, but both of them link with environments that we've already spoken about, tectonic settings we've spoken about. Passive margins ultimately links to mid-ocean ridges, and foreland basins linked to subduction zones. And then there's smaller percentages in other regions. And you can see the colors here, green is oil, red is gas, and then purple here is condensate, which is also economic. And so passive margins, there's more oil. That tells you it wasn't heated up that much, because oil forms first at lower temperatures. The fact that in a foreland basin there's more gas means that it was heated up to or buried to larger depths. Okay, so let's just look here, because I just told you that passive margins are linked to rifting, and I wanted to just show you how they are linked. So this is kind of like the steps going from the top to the bottom of getting from a continental rift up here down to a passive margin. So it's not that important, but on this left hand side here you've got your stretching factor, that's this 1, 3 and 4. So if you've got a stretching factor of 1, you're going to get an intracratonic sag, slightly bigger continental rift, slightly bigger, you might even get a failed rift. 3 and 4 you're moving to a passive margin, so it tells you there's been more stretching. So you'll remember in our class notes we said that all mid-ocean ridges start as continental rifts. So for example, the East African Rift Valley in South Africa is something like this. The continental crust is splitting apart and it's forming a rift. So surprisingly, mid-ocean ridges do not start in the ocean, they start on the continents like this. And then you might have a failed rift and nothing more happens here. You can see this dotted line, I'm assuming, is a asthenosphere or failed rising of asthenospheric material. But so you might land up with a failed rift where nothing happens and this crust starts splitting. But if not, and your continental rift keeps going and keeps going and keeps going, it's ultimately going to eventually in the middle here start producing basaltic material from the asthenosphere. You can see the asthenosphere down at the bottom here rises up and we start producing basaltic material, and you'll ultimately get an inland sea forming here, and as it gets wider and wider and wider you've got a big massive sea forming. So this passive margin picture here doesn't show much sea or basaltic material, but from what I understand a passive margin either looks like this, or if you've already got oceanic crust formed between, that's also on either side of it is considered a passive margin. And so in South Africa, our southern coast and our western coast are considered passive margins, because when Gondwana split apart, you got this rifting forming, and ultimately the whole on our west coast of the Atlantic Ocean has formed, and on our south coast is that the Indian? I'm not actually sure. Don't quote me on what oceans on our southern coast. But it's rifted apart. A little bit more has happened, which you'll see at the end of the slideshow. But we've got a passive margin on South Africa. And so I've also since learned that in a passive margin, the asthenosphere is rising up, but it's passively. It's not an active rising up of the asthenosphere. But I won't speak more about that now. Okay, so let's look. This is an example of a passive margin in the central Atlantic rifted continental margin of northwestern Africa. So we're here, you can see on this map is Senegal, the Gambia, and Senegal. And my West African geography is quite poor. So we're on the west coast, and this is an example of kind of what you've seen if we flip back, these rifts that are formed. So this at the bottom here is your basement. You've got rifting on top of it, and then you've probably got you've got active rifting down here, and then you've got the passive margin up here that's been deposited, and you've got yellow sandstone, brown is clastics, pink is evaporites, blue is carbonates, and then this grey is shales. And so you can see in this type of setting you could probably get a stratigraphic or a structural trap. It doesn't really list here where the oil and gas is coming from. Obviously these sandstone layers would be the reservoirs. It's interesting, here are wells that they've drilled, and they actually haven't drilled into the reservoir except over here. I'd be interested why they drilled in this region over here. So this is just to give you an idea of the geology of a passive margin. If we move on to a subduction zone, you've seen this picture before, but something I didn't point out previously is here on the left hand side you've got the subducting plate going downwards, you've got earthquakes in the Wadati-Benioff zone, you've got partial melting here in the mantle wedge above the subducting slab, and you've got the material rising up here into this volcanic arc. But, oh, and here is your trench that is forming with this, because of the subducting slab. Between the trench and this magmatic arc, you've got a basin forming here, and that's called your fore-arc basin. So this is also another area where you could find oil and gas. It was one of the smaller percentages of places. Then behind the magmatic arc, you've got thrusting over here, and this magmatic arc and this thrusting is putting a load on the crust, and the crust is bending and ultimately forming this foreland basin. Then sediments gets deposited here, and that helps bend the crust even more. And so this is actually an example of the Karoo Basin. So the Karoo Basin was a foreland basin. They call it a retro-arc foreland basin. I think that has to do with the direction of subduction, although that is quite debated. But this is where a foreland basin forms, and remember this was the type of basin had a lot of gas, because it probably the rocks can get quite deep here. Let's look at a different example. So here's South America, and in red here are is the hydrocarbon trend. So I'm guessing these are hydrocarbon plays. You can see oil and gas fields are these black blobs all along the side here. And you might say, well, why are they all here? Well, you'll remember in class we spoke about the fact that on the west coast of South America there's subduction. So this over here is the west coast of South America. So if this is the Andes, you can see the Andes would be running down this side. Oh, sorry, just behind it is the Foreland Basin. So that's what we're getting over here. And so you've got a long row of foreland basins, because you've got a long line here of subduction and volcanic arc. So this is where the oil and gas is. You can look down here, you've got the subducting Nazca plate, quite a complicated geology. Different blocks here, and Andes Altiplano. I really haven't looked at this diagram in much detail, but let's look where the Foreland Basin is. It's back in this region, or is this the thrust belt? I'm not 100% sure. It says of the Andes Foreland Basin, so maybe in this region over here where things are so thick in orange.